So in this video, I'm going to now explain how to decide about the increasing or decreasing pattern of a function without using derivatives. I have also uploaded a video in which using derivatives how to decide about monotonic functions or increasing and decreasing functions. Okay, now let me take the x-axis, y-axis, and I'm going to take the x-axis bit larger because I'm going to draw an increasing function, an increasing graph as well as a decreasing graph on the same rectangular system. Now let me choose 2 points, say A and B, on the increasing function and points C and D on the decreasing function. Now how to decide about whether it's increasing or decreasing using the coordinates we are going to discuss, that is without using derivatives. Okay, so for that let me drop perpendiculars from A onto the x-axis, from B onto the x-axis, and also C and also D. Okay, so if I'm going to take the coordinates of A as x1, and if I decide that the equation of this increasing graph is f of x and this is y equal to g of x, if this point A has x coordinate as x1, then the corresponding y coordinate will obviously be f of x1, and B, let it have x2 comma f of x2. It is very clear from the figure that these 2 points being x1 and x2, x1 is less than x2. Now what can we say about f of x1 and f of x2? From the height of this line, don't you see that that is obviously the y coordinate, that is f of x1. Don't you see that f of x1 is also less than f of x2? That is, for an increasing function, the inequality is maintained. That means if we choose 2 points in such a way that x1 is less than x2, we will be getting f of x1 is less than f of x2. Now coming to the case of a decreasing function, let me choose that this point has coordinates x3 and g of x3 because the equation of this graph is taken as g of x, and let this d be taken as x4 comma g of x4. Now it is very clear from the figure that x3 and x4 being the foot of the perpendicular from C and D, they will have, it was true that x3 is less than x4. But what can we say about g of x3 and g of x4? We are able to see that g of x3 is greater but g of x4 is lesser. That is, g of x3 is greater than g of x4. That is, if x3 is less than x4, we are getting for a decreasing function that the inequality will not be maintained, that g of x3 is greater than g of x4. Hence, for an increasing function, the inequality will be maintained, and for a decreasing function, the inequality will be reversed. We noted by an up arrow which is increasing function and a down arrow which is decreasing function. Now let me also choose an example to prove this. Let me take a function, say f of x equal to 3x plus 4. Now I have to decide whether this is an increasing function or a decreasing function without using derivatives. So let me just choose 2 points, say x1 and x2 belonging to the domain of f, and let x1 be less than x2. I am going to multiply 3 on either sides. Will it not give me 3x1 is less than 3x2? Now adding 4 on either sides, I will have 3x1 plus 4 is less than 3x2 plus 4, which will mean that f of x1 is less than f of x2. Therefore, this is an increasing function. Let me choose a case of another function, g of x equal to minus 3x plus 4. I have to now decide whether this is a decreasing function or increasing function. So again, let me take 2 points x3 and x4 belonging to the domain of G, and let me choose that x3 is less than x4. What will happen if I multiply minus 3 on either sides? Minus 3x3 is less than minus 3x4. Is this correct? Not. Because if we multiply a negative quantity on either side, the inequality will get reversed. So we will not get it to be less than. We will be getting it as minus 3x3 is greater than minus 3x4. Now add 4 on either sides. Minus 3x3 plus 4 is greater than minus 3x4 plus 4. That is, are we not getting f of x3 is greater than f of x4? Therefore, this is a decreasing function because we know if the inequality is not maintained, then it is a decreasing function.